So we're going to learn how to solve a system of equations using what's called the substitution method. And just like we showed graphically, we can either have 0, let's box that because that's very important. We can either have 0, 1, or we can have infinitely many solutions. It's very important. Using the substitution method, or any method, we're just using a different method to solve it. So let's go to the next slide. Okay, so let's give an example of, let's go for 0 solutions first. Here's going to be an example. And let me show you why. Okay, so if we have y equals 2x plus 1, and then we have 6x minus 3y equals 1. Okay, so we always want to go about these the same way. See how y is by itself? You want to kind of highlight that other side and keep in mind that you're going to substitute in the other equation, okay? So we're going to put this one in this equation. So 6x minus 3, you can leave some space, right, equals 1. We're going to substitute this, right? So let's put it in there. Let's put 2x plus 1. Now we got to do the work, right? 6x minus 6x minus 3 equals 1. Look what happens. This goes away, right? It's 0. We get something that makes no sense. So if we get something that makes no sense, okay, we say right away, we know it's 0 solutions. Okay? Those lines would never meet. They'd basically be 2 rows on the graph somewhere, okay? Now let's go over another case. Let's find out what this one, I'm not going to tell you first. Let's find out how many solutions this one has. So we're going to have y equals 2x plus 1, right? And then we're going to have 6x, let's make this, minus 3y equals negative 3. So again, this is our important part, right? We're going to substitute that in the other equation. So 6x minus 3, 2x plus 1 equals negative 3. Let's do the work. 6x minus 6x minus 3 equals negative 3. Look what happens. This goes away, right? This is just nothing. So we're left with negative 3 equals negative 3. When this happens, when we just get a true statement, we say automatically infinitely many solutions. So these are actually the same lines in disguise, okay? Infinitely many solutions. Now let's go over the case where the lines are going to cross and we have to do a little bit more work. So y equals negative 3x minus 1. Sorry about that. Minus 1, okay? And then 2y plus 3x equals 12. Alright, same exact idea. Let's use a different color this time. I'm getting bored of that color. Let's use that color because it's cool. So we're going to highlight this, right? We're going to end up substituting that into this equation, right? So 2 times negative 3x minus 1 plus 3x equals 12. So this time we got to do a little bit more work because it will end up working out. Negative 6x minus 2 plus 3x equals 12. Don't forget these are like terms, so I'm going to put them together. I get negative 3x minus 2 equals 12, right? Plus 2 plus 2. So negative 3x equals 14. You got to do the work, finish it off. X equals, doesn't matter if it goes on the top or bottom, so I'm going to leave it like this. Right, now we got to find y. So you can substitute in either equation. I'm going to use this one. So negative 3 over 1 times my new x value, negative 14 over 3 minus 1. running out of room there. So what do I get? I get 52 over 3, right, minus 1. Let's make it 3 over 3. We can do that, can't we? So we get, running out of room here, we get 49 over 3, right? And that's our y value. So let's put it all together. Negative 14 over 3, comma, and 49 over 3. Alrighty? One more. Let's do one more example. Okay? So let's make it y equals 2x plus 1, 2y plus 4x equals 12. Right? Same exact idea. Nothing's changing here. We want to substitute this one in this equation. So 2, make a little bit of space, plus 4x equals 12, right? Let's use this color. So 2, we want to substitute this part in here, and we get 4x plus 2 plus 4x equals 12. These are like terms, right? Just a little bit of clockwork here. Got to be careful though. So we get 8x plus 2 equals 12 minus 2 minus 2. 8x equals 10. So we finally get, I'm going to reduce this, we get 10 over 8, or we can divide by 2 to get 5 over 4. I'm going to leave it like that, right? We got to substitute in either equation. Why not use the easier one? So I'll write it all out this time. Y equals 2 over 1 times 5 over 4 plus 1, right? So I get 10 over 4. I'm going to make it plus 4 over 4 so we can just solve it better. And I get 14 over 4. So this is x, this is y. Let's put it together. So I get 5/4, comma, 14 over 4, comma. Right? This is my final solution. All right?